In this lesson, we'll continue to examine rotations. So one of the most interesting rotations, algebraically at least, is, and you'll see it explored in many of the textbooks, particularly at the middle school level and even the high school level, is when we rotate about the origin, because then nice algebraic things happen. So if you take a look at this figure, it appears to be maybe a trapezoid, and I want to think about rotating it about the origin. What would happen to all of the points? And well, if you can figure out what happens to two of the points, then you have a chance at figuring out what happens to all of the points, because then you can kind of map the figure with it. So I want to look in this video at 90-degree rotations. We're going to look at 180-degree rotations and then 270-degree rotations. 360, kind of boring. You're back to where you started. So for all of these, we're going to be going counterclockwise rather than clockwise. That is the standard that we would do there. So the way that you get it done is think about where a point is now. Let's start with A. And if I were to rotate that 90 degrees about the origin, where would I end up? So the idea is, if you think about the line segment connecting those two, and you were to draw, and again, we're going counterclockwise. If you were to draw another arm so that it looked or appeared to be 90 degrees and you ended up at the same length, where would that end up? Now, I don't know that I drew that perfectly. In fact, it doesn't look perfect. So perhaps if we use counting a little bit, we could determine it a little bit better. So let's try that counting wise. Well, if you count the points, 1, 2, 3, 4, 1, 2, 3, 4, 5, it appears to be back 4 and up 5. And so if you remember your perpendicular idea, you would just do 4 and 5, but perpendicular, you kind of switch those and go 5 and 4. So 1, 2, 3, 4, 1, 2, 3, 4, 5 would be right here. That's 4 and 5 the other direction. And then there you have your 90-degree angle. And then you'd have to do that for all of the points. That would just be A prime. You would do something similar for B prime. So there's B. And if you think about, maybe I'll draw this in a different color. I'll try the green here. If you think about this line segment, what would happen if I did 90 degrees the other direction instead of 2 and 1, and that like that, I would do 1 and 2 the other direction. So let's see where that would take us into the other quadrant, right here. All right, and that would be your 90-degree angle right there. And there would be your B prime. And if you did that for all of the, points, you would have your new translation, your new rotation. So it's way easier on GeoGebra. So let's take a look at that as well. All right, so here is a segment. I have it in the fourth quadrant. And if we look at a 90-degree turn right here, look and see what happens to A prime and B prime. It's, I think, pretty fun to examine what's going on with the numbers. So let me get my pen turned on here if I can find it. There it is, my pen. So initially A was at 2, -4. All right, and we look at where it is now, A prime, the image 4, 2. And you're like, okay, that's interesting. Numbers are the same. Something's going on there. Let's examine B and see if we can find a pattern. B was at 3, -1. Now B is at 1, 3. Well, what do you notice? Well, it looks like the integers are flipped, and then we also have a negative sign. Yeah, that's what happens with a 90-degree turn. 90 degrees, we have any point x, y. What happens is the y and the x are flipped. First of all, you notice that, right? They change positions, and then it becomes negative to the right-hand side. So it becomes negative x. So what would happen with 180 degrees? What would happen with 270 degrees? How do those look? Let's just take a brief look at those as well. All right, if we move our slider over to 180, and we did this in the previous video, what you notice is that the points are exactly 180 degrees. So it's like diagonal across the origin. And A is now at -2, 4 rather than 2, -4. And B is at -3, 1 rather than 3, -1. So all that happens there is a sign change. Okay, so we have, well, got to turn my pen back on, but we have any 2 points or any point x, y. What happens to it is now the x and y have changed signs. And if you examine the 270, and I don't have time in this video, I would challenge you to do that and think about, what happened to those coordinates when I did that?